Okay. Find one cot alpha. So if you are given a trig ratio, that is not a special ratio, and you're also taught the quadrant, then you form a triangle in that quadrant mentioned. And this is alpha. And then you have 90 here. Sine is opposed over hypotenuse. Then you find the missing side, which is 5 squared minus 1 squared. Then you get the square root of it. This is 25 minus 1 square root, which is root 24. So we have root 24 here, like that. Now cot, we know cot is 1 over tan, or since we have SOHCAHTOA like this, SOHCAHTOA. So to avoid learning new things at this stage, we'll just say we know cot is 1 over tan. Okay, so this is 1 over tan. And since we know that tan is opposed over adjacent, so we'll write 1 over root 24. So that this just becomes root 24. But look, this is negative, so we put the negative as well. It's negative because it's on the left of the y-axis. So it's negative for that matter. That is B, cos 2 alpha. Now look, the angle given is alpha, and you are told to deal with 2 alpha, a double angle. So you do cos alpha plus alpha, which is cos alpha minus sine alpha. This is the same thing as cos alpha we get from the, so cos alpha will get from the triangle. Cos is adjacent, negative root 24 over hypotenuse multiplied by cos over that minus sine, it's given in the question, 1 over 5, 1 over 5. So together we get 24 over 25 minus 1 over 25, which is 24 minus 1, we get 23 over 25. Now today there was sine and cos. The day you find tan 2 alpha, remember that it is tan alpha plus tan alpha over 1 minus tan alpha tan alpha. Okay. If you find sec 2 alpha, remember that it is 1 over cos 2 alpha. If you find cosec 2 alpha, remember that it's 1 over sine 2 alpha. So don't expect that every time you find cot and cos. No, you can also find sec, cosec, because these, they have written this today.
Sir.
Hello.
On part A, what if it was negative 1 over 5? How would you consider the negative, since there you said it's on the negative side of the y? So how would it be?
You wouldn't say that for sine. If they say that, then it can't be sine. Maybe it has to be cos. Maybe they can say that for cos. They say cos alpha is negative 1 over 5. So that when you put the quadrant, you're saying this is negative 1, that is 5. And this will be the 24. Because remember, sign is positive in the second quadrant, so they can't make a mistake to call it negative. That's the basic thing there.
So sir, when you're given a sin 2 theta, also you can't say 2 sin theta cos theta.
If you are given
You're given a sin 2 theta. So
sin
for
2
this
theta, sin 2
problem,
theta is the same here. Sin 2 theta is 2 sin theta cos
sin,
theta. Because we understand that because of that identity that sin A plus B is sin A cos B plus cos A sin B. So if these are the same, then you have the same thing, so you can add them.
so even that one can work.
No, not in this cos 2 theta. It can only work if they bring sin 2 theta.
Oh, so cos 2 theta can't work.
You want also cos
Okay.
2 theta to be 2 cos theta sin theta.
No, like its identity, which is it's double angle identity. Isn't it cos squared minus sin squared? So
It is.
then we replace the thetas according to the triangle, the values we get.
Yeah,
Will the solution be the same?
that's what we have here. We have
Of
cos
course
times
they
cos,
are.
which is cos squared.
Oh, okay, so I see it. Okay.
Yeah.
Okay.
On the negative root 24, you are getting, for you to get a side, if you're using Pythagoras theorem, you square this minus the square of the other side. Then you get 24. But then your conscience cannot let you free if you have this as the x or y plane. This is x, this is y. And then you put 2 here on the left of the y-axis. Your conscience can't allow you to do that. This is 0.
So
to the
sorry,
left, it's mine.
why are we squaring 5 and 1?
To get
I mean, inputting a square root. Why doing that?
The Pythagoras theorem. Says that if you have a right angle triangle where this is A, B, C, you say A squared plus B squared is equal to C squared. So if this one is unknown, then you say A squared is equal to C squared minus B squared. Because you want A, you square root minus B squared. So it's actually a theorem. Is it okay?
Yeah, it's okay, sir.
Okay. Let's go to B. Solve the following trigonometric equations for 0 less or equal to x less or equal to 2 pi 1 sin x is equal to cos of negative x cos is even, is it? So cos of negative x is the same thing as cos x, since cos is even. So we have sine x is equal to cos x. And when does that happen? That happens when x is equal to 45. Okay, now we're told it should be in pi. So pi over 1/8, giving me pi over 4. Where else is sine equal to cos? They are also equal in the third quadrant. That's why they will all be negative. So I follow up in the third quadrant and say x is equal to pi plus pi over 4. Remember 180 plus 45. So you get 5 pi over 4. As a solution. So you can't say cos and sine are equal in the second quadrant because sine there is positive, cos is negative. Come in. Cos is negative and then sine is positive there. So you can't say those are equal. You get that?
No, so like, excuse me, sir.
Mhm.
I'm confused on the second one.
Here sine, cos are positive. Come in. Then here sine is positive. Then here come in. Sine and cos, they are negatives. Then here cos is positive. So we want where they have the same sign. They have the same sign. Like that.
Sir,
Hello.
why are you adding pi over 4 on the second one? 4 pi plus pi over 4.
So the pi is 180. Remember in the third quadrant, how do we get the reference angle here? We add 180 plus the theta. So because our theta is 45. So if you want the big angle in the third quadrant, you add the small angle to 180 to get the big angle.
All right, sir.
They're confused on 45. Sine 45 is root 2 over 2. Cos 45 is also root 2 over 2. So the two are equal. That's why we've picked 45 because we know that the two angles are equal. They are at 45. Any other angle where this can happen, it should be at let's try. I remember just saying things that are not clear. What is sine 120 180 plus 45 is what? Is 225. So what is sine 225? Sine 225 is, so if you're given 225, you get a difference angle which will be 45. Negative. So we get negative root 2 over 2. If you have cos 225 again, that will be again negative cos 45. Yeah. So that's how it makes sense. So we respect the signs of these in each quadrant whenever using a small angle. So it should be nice that way. Okay, what about the second one? 2 of the same question. Cos x plus sine 2x is equal to 0. So you write cos x plus what is sine 2x? That is 2 sine x cos x is 0. Then cos is common. Then 1 plus 2 sine x is 0. So you're saying cos x is 0 or 1 plus 2 sine x is 0. Meaning sine x is negative 1 over 2. Like that. So that's how it following this. The compound identity is sine A plus B is sine A cos B plus sine B cos A. And so if I'm dealing with the same thing, if it's x plus x, I'll have sine x cos x plus sine x cos x. These are the same, and there are two of them. I can add them like that. Because I know on the rest, when I say x plus x, I'll get 2x. So this becomes an identity for that one. So you substitute here. And then because I have, it's like you have x plus 2yx is 0. Obviously, x is common here, so I can factor out x and remain with 1 plus 2y is 0. Now you need to find the angles. When is cos 0? So you know cos 0 when x is 90, which is pi over 2. Well, that also happened at 270, 3 pi over 2 from the big 5. And then sine is half at 30. Okay, which is at pi over 6. But now we're talking about negative. So it's negative in the third and fourth quadrant. So in the third quadrant, we have pi plus pi over 6, which is 7 pi over 6. And in the fourth quadrant, we have 2 pi minus pi over 6. That is 12 minus, and that is 11 pi over 6. So we get this 1, 2, 3, 4. So those are marks we're counting. Then we go to C. State the period, amplitude, phase shift for the graph of this function. Hence, sketch the graph.
So the moment you do that, you're done with the answer.
Yes.
The question, everything.
You get 7 marks. C, we're given f of x is equal to 1 plus cos x minus pi over 4. And they're asking for the period. So the period is 2 pi over 1, which is 2 pi. What else do they want? They also want the amplitude. Well, the amplitude is the absolute value of 1, which is 1. So you keep checking what they're asking for. Phase shift, you start with the horizontal shift, which is x minus pi over 4, equated to 0. So x comes out to be pi over 4. And then vertical shift, and that is just 1. So you have given all the properties. Then now they're saying, hence sketch. So you just add one thing, you find the scale. Hello.
How did you find the periods?
So the period is, the formula is 2 pi over b, where b is the coefficient of this x inside here. That coefficient there is 1. As you can see, we have 1x.
All right, thank you.
Okay. Okay, then now we sketch. So say the simple sketch of this. We have this as pi over 4, the first shift. So it starts from there. And then I have the scale to add to the first shift. So I'm adding now pi over 2 plus pi over 4. You get, what do you get? So you have pi over 2 plus pi over 4. The common denominator is 4. And then 2 there, we get 2 plus pi. That gives us 3 pi over 4. Okay, then 3 pi over 4 plus pi over 2. You get 5 pi over 4. 5 pi over 4. Then 5 pi over 4 plus pi over 2. You get 7 pi over 4. 7 pi over 4. And then 9 pi over 4. At least we have, from the first shift, we still have 4 more important points. Okay. Then, well, if I pick the first one, I know because the amplitude is 1, so I know that the maximum value here should be 2. If I don't know, I just calculate. So what is f of pi over 4? That is 1 plus cos pi over 4 minus pi over 4. This is 0. So I have 1 plus cos 0. Cos 0 is 1. So I get 2. So this is comma 2. Comes there. When we put 3 pi over 4, we have 1 plus cos 3 pi over 4 minus pi over 4. That is 1 plus cos 4, 3 pi minus pi, that is 2 pi, giving us 1 plus cos 90. Cos 90 is 0. So we get 1. So we get 1. So now the next one is going to give us 0. We substitute 5 pi over 4. That is 1 plus cos 5 pi over 4 minus pi over 4. That is 1 plus cos pi. And cos pi is -1. So we get 0. So we have a 0 there. So now we have 3 different values. So the next one will get back up and then back up. So the graph is going to be just a flat thing here. That's going up. The same graph, just that my x-axis is a bit wider, so that's why it does look like a depressor.
So
Hello.
how is cos pi equal to -1?
What is pi?
And how is cos pi equal to -1?
So pi is 180. You understand that?
Yes.
Yeah, and cos 180 is -1.
Oh, okay. Thank you. All right. Thank you.
Okay. Wow. This paper was very easy. But if you're not careful, it can mess you up.
So,
Hello.
how did you know that you're supposed to end at 9 pi over 4?
Because they haven't given us n scale, so we just make sure that we have one complete oscillation.
Okay.
Yeah. Okay, let's go to question 2. Yeah, time maybe not that much. No, it's not 50 minutes, it's 1 hour. So it's not that me I'm explaining here. That's why it looks like slow. But there's nothing. Solve 1, 2x minus y is equal to 0.5 and 3 power x is equal to 9 power y. Solve the simultaneous equation. So this you can write it as 2x minus y is equal to 0.5 is 1 over 2. Okay. Because of the power, you can leave it in this form. Is equal to the power negative 1. So that you know that x minus y is equal to negative 1. Then you leave it there. You go and touch this one on the right. So you can write 9 as 3 power 2. Which is 3x is equal to 3 power 2y. Bases are the same, so x is equal to 2y. So now I have these two equations. This one and this one. X is 2y. So you bring it here and say 2y minus y is negative 1. So y is equal to negative 1. Then substitute x is 2 by negative 1. So x is 2. Negative. Simple.
Sir,
Hello.
use elimination.
Huh?
Can you use elimination?
X minus y is equal to negative 1. Then you write this as x minus 2y is equal to 0. You can subtract x minus x, that is 0. So that will remain with negative y minus 2y is equal to negative 1. Plus negative y plus 2y is equal to negative 1. Then this is negative 1. Masa. Masa, what is you talking about? So y is equal to negative 1. Then you go and get x. The elimination, you do anything, you subtract, you add. Anything can happen there, depending on what you have to eliminate. So this was easy if you thought about it in this way. But it was tricky if you think about it in dropping powers. You drop a power, drop a power, drop a power. Oh, yeah. Can mess you up. The answers can be bad. Anyway, maybe that can be good. Who knows? Can try it out in the quiz. Let's do the second one. log x minus y 2 is equal to log 10. So when you're given no base, you know the base is 10. So this is like log x minus y, log 10, 10, that is 1. So you have x minus y is equal to 2 to the power 1. So x minus y is equal to 2. You can take the other one. The other one is log x3 is equal to log y9. Oh, but we know that we can write 9 as 3 to the power 2. So you can write this as log 3 power 2y. Then use that property where we can take the power away from that so that we get half log y3. So that one goes up. So it remains x is equal to the root of y. So that if you square here and square here, you get x squared is equal to y. Then you substitute here. You have x minus x squared is equal to 2. So that when you factor out, you don't factor out. Yeah, it's like a quadratic now. So you have minus x squared plus x minus 2 is equal to 0. The product is 2 and the sum is 1. We can use 2 and I don't know where I've gone wrong, but my answer looks wrong. Where is the half coming from? The half coming from this one, 3 to the power 2. You can write it as this. So y is equal to x squared. And here I have x minus 1. Hello.
I'm kindly asking if you can explain how you got half of log 3, half log base 3 of y on the right side.
So the video is starting just before I start explaining. So let us log back. And then we'll finish up in the
All right.